Hello everyone, here we have our Ollie detection sensor taped to the bottom of the skateboard. Here we have the raw data of the Ollie detector sensor attached to the bottom of the skateboard as the skateboard performs multiple Ollie tricks. The resolution of the sensor is 0.4 degrees, the measurement range is between positive and negative 90 degrees, and the bandwidth of the sensor is between 10 Hz and 50 Hz. In the raw data, we could see on the top plot the acceleration of the skateboard. There's a large Z acceleration, which is colored in green, which indicates the landing of the skateboard, which is a strong force as the skateboard hits the ground. On the bottom plot, we have angular velocity. In angular velocity, we see that there's wide variations in the x angular velocity, which is the axis that the skateboard is rotating in during the Ollie performance. During this trick, the skateboard rotates upwards in the x direction, then levels out horizontally midway in the air, and then lands back down horizontally. The higher order information, we will first integrate our raw x angular velocity data to give us the angular orientation of the skateboard. After this, we will find the index of the minimum z acceleration data, which will represent the instant that the skateboard lands back on the ground. Following this, we will make a new array of our angle orientation values only 1.5 seconds before this landing to capture only the time of the Ollie. From here, we must determine the angle orientation of the skateboard and whether this orientation is ever in the range between 0 and 10 degrees. This will be the range we use to say that the skateboard is horizontal before the board hits the ground, signifying the user performed the correct Ollie. The board, however, will be in this angle range twice, once when it first angles upwards to jump, and a second time when the board begins angling back towards being horizontally. To find if the angle orientation is in the correct range the second time, we also must test whether the angular velocity is positive in the x direction. The combination of both the accelerometer and gyroscope help reduce the error of the sensor by being able to filter out any unwanted signals. The skateboard will be able to be turning in the z and y direction while the skater is skating. However, there is only a drastic change in the x direction when an Ollie is attempted. Thus, to know when an Ollie is attempted, we can use the large spike in the z direction to know when we can inspect the x angular orientation. The MATLAB code to the left shows the code used to run the process to figure out whether the Ollie was successful or not. With the skateboard data I used, I was able to perform a successful Ollie, which printed out sick Ollie at the bottom of the code. The plot on the right shows the angle orientation of the board for a 1.5 second interval. The Ollie begins at approximately 0.7 seconds, then the angle magnitude increases until the user kicks the skateboard to push it towards a horizontal orientation while still in the air. The skateboard then reaches horizontal orientation as it reaches 0 degrees before it lands. The landing occurs at the end of the plot. The idealized system would incorporate the Pocket Lab, including a microcontroller and a sensor. The microcontroller would be able to read the data coming in from the sensor and determine whether or not the user completed a complete Ollie. If so, the microcontroller would talk to the speaker it's connected to and give live audio feedback to the user to allow the user to know whether or not they performed a successful Ollie.